and welcome back to Verbose DevOps. Today I want to talk to you about curl and how it's used for DevOps. Now curl is one of the most common and important Linux commands, especially for DevOps and cloud. And you will use it in the terminal just as an operator. You may want to test something out quickly, or even as well in scripts too. So you do definitely need to know about this. You might get interview questions, but forget about that. You're going to need it in your job anyway. So if you don't know about curl, this is the video for you. So what is curl? It just means client for URL. Basically, it's how they made their name, and it's a command line tool used to transfer data over various protocols, and you'll specify a URL, which is the endpoint you're communicating with, and it's commonly used for sending HTTP requests to REST APIs, but also to websites. So I don't know if you're familiar, but a website and a REST API, they're really almost the same thing. You know, you have a client like you or something else that communicates with a remote destination, let's call it a server, and whether it's a website that is serving graphics and video and articles, or a REST API which may just be spitting out a very raw text information in JSON format. They're really pretty similar things. They just do different jobs. So let's first cover how to send a request to an API, because you'll definitely be doing this. And what you typically do is set the method, so it could be get or post or put, and if you don't know what these are, I do recommend reading them separately. But basically a get is when you are requesting information, and a put, like you do in your web browser for example, that's a get. And a post and a put is kind of similar, but a post is when you're sending information. So if you're filling in a web form and you click a button, that would be a post operation typically. So you have to specify that with -x method. You can get rid of the space. So for example, you can put, I gave an example, curl-XPOST. The default, by the way, is get. So if you don't put anything, the default is get. Okay. Now, when you are sending a post request, so you're sending data, you also want to send a payload, and you use -d for that. And I've given some examples there of key value pairs. The first example looks a bit janky. The second example is using braces, so that's like JSON style. The third example, data.txt, is when you want to send a file. Okay, it could be a text file, it could be a binary file, but you need to put an ampersand before it, and that way curl knows what you're trying to do. Now, you might also want to send a header in your request. For example, if you're sending JSON data, it is typical to say content type application JSON in your header. Or let's say you need to authenticate. To be authorized, you will typically put that in a header as well. So for example, an API key, and depends what the API wants, the format, but that is quite typical what I put there. Or you might put in there a bearer token if you're using like OAuth2 or a PAT token, for example. With your CI/CD solution, it's quite common to use a PAT token. Then that's how you would put it in there. You would put it in the header of your request. So let's do a demo of this, because I think that's going to demonstrate better. So I do have here a little example. I'm going to use a fake API, by the way. Let me show you that. This is the wrong page, but this is an example of JSON placeholder. It's a free and fake API, so I do definitely recommend it. So let's go here and let's paste that in. So we're going to do a get request. Remember that xget is actually, in this case, default. We could just get rid of that, but we're going to do it on this API here. And that's what we get. Actually, we've got a lot of stuff there, so let me clear the page again and let me just replay that command. But we're going to put a /1 on the end. And here we go. We're getting back post number ID 1, which is basically what we requested in that URL. So think of this as like a blog post, a title and a body. If we wanted to get, say, post number 7, okay, we could do it again. It'd come back with a different post, ID number 7, with a different title and a different body. So it gives you an idea of making an API request. Now, you don't always do an API request like this. It could be done using curl in a bash script, or it could be done even programmatically using Python and then calling curl, or using a library instead, and then you wouldn't be using curl. But you get the idea that curl can be done either by you as a human operator, or it can be done in a script. So let's go back to the slide. Oh, sorry, I should say let's try a post operation now. I'm going to copy this, go back to the terminal, let's clear the screen, and what we're doing here is pretty similar. So it's the same URL as the first one, the one that returned a whole bunch of posts, but the difference here is that we're now saying it's a post type operation. We're saying that there's a header to say we're sending JSON data, and in the payload here we put in a JSON style using braces, 3 key value pairs, title, body, and user ID. So let's press enter, and in a typical API fashion, what it's done is it's returned us in the response exactly what we sent to it by way of confirmation to us, and it's also returned to us an ID to say, well, you know, in case you want to retrieve this later with a GET request, this is post ID number 101 that we've stored in our database. You know, and the way you would do that typically, if I just go back to here, what you would do is, you know, you would say post number 101. So let me copy that. Let me clear the screen. That's how you would do it. You would say do a GET request, and I want post number 101. Now, if I do that, it returns nothing because it's a fake API. It didn't really store what we just sent to it, but usually you would expect that. One other quick word to say is that you see here, I've got another example. Let me paste it so it looks a bit bigger, but I've got another example, and you can see that in this time the document, the JSON, is separated into several lines, which is more human readable. It's how you would store it as code, and if we do that, so it's not a one-liner, it's spread out over several lines, we get the same response. And the reason for that is the APIs, if they're expecting it to get JSON data, it doesn't matter if you separate it over several lines. It knows how to parse what you're sending it. It knows that these commas, for example, are separating the key value pairs. So no problem there. That's just JSON working beautifully. So let's go back to the slide. That's the demo of sending a request. I want to show you also some other functionality that we're going to demo. So by the way, just to start off with, the default behavior, whether it's a website or an API, is GET. Now, I already mentioned that, but let me just demonstrate that to you, right? So if I go curl google.com, then we get this, and you can see that that it's returned http://google.com. So if I had done that instead, we get exactly the same thing. So you can see by default, if you don't have the prefix, it will assume HTTP. Now, if I want the secure version of the site, put in the S, then I have to be very explicit. And you should be explicit anyway. And you can see here, it's returned the one that has the S. So that works fine. So let me clear the screen. And I mentioned there in the second line that it's based on what you're putting in the URL. So the other thing to know is that you will by default get only the response body, okay? And you need to put in -i if you want the headers only. So let me give you an example of that. So if I type this in, this gives me the headers. So remember, we're getting a response back, and the response that comes back normally is the body, but if we want only the headers, we use -i. And the reason I show you this is because it is quite typical actually for a DevOps cloud engineer that you won't really be interested in a big, huge page. In fact, quite typically, you're not interested in the content at all, especially if it's a website. And more typically, you will be interested in just the header of the response, which is what we're getting here. And in the header, what you get is the it shows this response code and some other information as well. So this is much more useful, and you may well use this more often if you're doing some kind of investigative work. So Let's go back to the slide. Now I want to show you here there's something called a user agent, and there's two ways to specify that, and one is dash capital A, and the other is to use dash capital H for a header and then specify as user dash agent. This is the convention. Now let me give you an example of that. I've got one here. I'll paste in the terminal so it looks a bit bigger. Let me clear the screen. So you can see there what this is saying is that it's Mozilla Firefox running on Windows. And when you use your browser and you visit all these websites around the world, all those web servers in their logs can see the user agent of who visited them. It's useful information. It's basically identifying information. And not only humans will use this, but also applications will send a user agent. Even search engines like Google, when they're going around crawling the web, will also have a user agent to say, hey, we're Google, don't block us, that type of thing. So you might find a use for a user agent, whether you're human operator or whether for your application. It's a good way to test also if your application is serving an appropriate response. You might be giving different responses. For example, if someone is using a phone or they're using a laptop. There may be other ways to tell if they're using a different device, and I'm actually not sure from a developer perspective whether using the user agent is a good way to tell what device someone has, but it definitely is one way. And let's say your website is going to serve slightly different depending on whether they're using Chrome or Firefox, then the user agent is definitely the place where you want to look to see what the client is using. So there you go. Let me show you. Let's carry on. If you need to send a cookie file with your request, then you would use -B. Not used very often, but I think it was definitely worth mentioning. Now, to download files, you're going to use -O. Let me show you an example here, right? If I go to, this is just an ISP that provides download test files. This is quite common, and you might want to use these in your utilities as well, your own tools. Let's say you want to test an internet connection and download a large file. In this case, I'm going for a small file. I'm just going to copy the link for a small file on IPv4 port 80. We're not interested in other ports right now, so if I want to download a file, then I can just do curl like that. But actually it's going to warn me that because I think it's because it's a binary, it's actually asking me to specify, because it knows it's a binary. It's saying, look, I know it's a binary and you don't want to display all this garbled text all over your screen, so specify a file to save it, and that's how you do it with -O. So I'm going to say save it to here, and you can see this is kind of progress indicated. There is another option to have a kind of bar, but by default this is what you get. And if I do an LL, then we can see there is the file in my directory. Now, something else that you can do, if I just edit this, if I go -S, this means silent, and I do that again. Oops. Oh, I messed that up. I messed that up because that is supposed to be where the output is. So let me put it there. And if I do that again, then look, looks like nothing is happening because it's basically suppressed or silenced the output that would have showed us the progress. I mean, maybe you don't believe me. What I should do is create a new file name, call it silent, and do that again, and wait a few seconds. It's going to come up now, and there we go. And let me do this. There we go. Let me look. There you go, silent. And it downloaded it, but it didn't give us any of this stuff here. So that can be quite useful. So let's go back here. There is a variation on that switch, which is to use a capital S, and that's to say, yes, I want to silence it, but if there are errors, I do want to see those. So normally if you use just small s on its own, it will suppress everything, including errors. But if you want to see the errors, then you need to use this dash small s big S. Now dash L is a very, very important switch, and I'm going to show you why. Because it's very common. I mean, we saw this with Google, right? If I do a curl google.com, you see that we got a 301. And a 301 is actually an HTTP status code for a redirect. So what happens is curl does not recognize redirects unless you use -L. And if you don't, the default is it will just stop. So we got this response that said the page moved and you're about to be redirected, but curl just didn't do anything. And that's quite common on a lot of websites. So for example, if I type curlcnn.com, you're also going to see that basically it looks like nothing happens, but actually it wanted to do a redirect, but because we didn't say anything, then nothing happened. So I'm going to show you now an example. So let me clear the screen. If I do curl, this is another website. I did find a nice example. So this is a UK website that is good for IT news, and I do that, we get a similar thing, right? That 301, the page has moved, and even tells us it's Apache server, which is quite nice. However, if I do a curl big L, in fact, let me just page up, that's easier, and insert a big L, then what we're going to get is we're going to get the website. So it followed the redirect, which is a lot better. And whether you're wanting to curl a website, or as you're going to see later, downloading a file, this can also be super useful. So let's go back to the slide. And in fact, you know what? I think I'm going to show you this right away because I do have an example stored up. So let me go to here. So this test file was a direct link. There was no redirects involved. However, it's very common around the world that when you go to a download page, that there'll be a redirect to a location that is closer to you, so that it's a much faster download. It's extremely common, right? So it's not only websites that are doing this, but also downloads that are doing this. So what I'm going to do here is get the link for Golang source code, and I'm going to copy that link, and let's clear the page. I'm going to paste that in there. So that is the link, and if you look, it says that it's under go.dev/dl/ the file name. Now, maybe that's true, that it's under a directory called DL and it's just sitting there, but you can already see that it's kind of too good to be true. In actual fact, that's probably not a real directory. That's probably some code that's sitting in there that is then going to redirect us, and I'm going to prove it. So if I do a curl on this, and I'll just run a curl normally, just to prove it. Okay, you might be expecting it curl to say, "Oh, binary data, you should use -o," but watch this. It actually was a text response, because that URL is not a file. It's actually a web page, and it's returned us the web page, which is a single link that says, that this is the website. So, and if I had just gone like that, curl o, and called it go download.tar.gz or something, and then that URL, we might have thought, wow, that's a super quick download, look how quick that was, right? But it wasn't, because if I go and look at it, it's the same. It's just that text, the HTML. So what we need to do is, and I'm going to clear the page, we need to go curl L for location, or I like to think to follow, the L in follow. That's my way of remembering it. And then I'm gonna call this followed.tar.gz, and then we want that there. And watch what happens here. You see that it actually does two things. The first row is the original URL that just had that one line of HTML text, and then it redirects and it actually goes to the download, which is 30 megabytes. And if I do an LL and look, and you can see here that the original one is a mere 67 bytes, and the actual download is here, and it's 26 megabytes, or 27 million bytes, or whatever. So now you can see that this -L is super important, not only for curling websites, but also for downloads as well. So let's go back to the slide. One other thing I wanted to show you was -F, and that what this does is it will return a non-zero exit code for an HTTP error, and errors are 400 and 500 status codes. 400 series means it's a client error, and a 500 series means it's a server error. I recommend googling HTTP status codes if you just get an overview of 100, 200, 300, 400, 500 type codes. But I'm going to show you an example now of where this could be useful. So let me go back here and let me clear the screen. And what we're going to do is we're going to curl google.com again, right? And it returned a 301, which is a redirect. Now that's not an error, okay? Now if I do this command, this is a Linux command, and what this will do is it will show them the error code for the most recent command run. So I get 0, and 0 is typical for a command that ran with no errors. It's just absolutely typical. Now if I do again google.com, but what I'm going to do is I'm going to invent a non-existent full URL. I know this page doesn't exist, and Google should give me a 400 error. I think a 401, or I think a 404 if I remember correctly. I should know this, but anyway. So if I do this, there you go. It came back with a 404 not found error. So what if I do this again and look at the operating system error code? I get a 0, because normally with curl, even if it finds a 400 an HTTP error, it won't release an error, an exit code, a non-zero exit code, which would normally indicate an error. It will still say 0 as if to your operating system command was successful. So if you want it to give you a non-zero exit code, then what you do is you can run the same command, but you run it with F. And actually it has an added effect in that it also suppresses the output, the response. I'm not sure why it does that. I think it has an idea that you're probably going to use this in a script and that you don't care about the response. But let me run this again, this echo $? And you can see now that it returns an exit code of 22, which is actually the same as curl returned to us. Now what I didn't say is, why would you care about getting non-zero exit codes for curl responses that are errors? Why would you even care? And the reason is, if you're using a script, then exit codes are quite important, and you might want to change the logic of your script depending on whether you get an exit code. So for example, you may want to exit the entire script if you get an error. That's one example, but the exact logic is down to you, but they're very useful in scripting. So I hope you found that interesting. I just want to say here that it's quite common I see this a lot, that when you're downloading public keys to run curl FSSL, so obviously that means you know, if there's an F, then return a useful exit code, suppress the output unless big S, unless it's an error, and L follow a redirect. So yeah, you can see why this is often shown as an example. So I've got one here, for example. Look, this is something I've seen on the Elastic is some open source software, and one of the commands that it asks you to run is this, and it's basically to download a public key of theirs. And you'll just see this a lot as a very common example, and I see it a lot in the use case of downloading public keys. So I just thought I would share that with you, because downloading public keys is something that you're probably going to script for as a DevOps cloud engineer. It's pretty typical. So let's move on to I think this is the final slide. What are the alternatives very quickly? In PowerShell, there is an alternative to curl, and it's called invoke-rest method. I just wanted to say here that this does everything that curl does, but the name is a little bit confusing. It makes it sound like it's only to be used for interacting with REST APIs. That's not correct. It can actually be used with any HTTP endpoint. So it's not only REST APIs. So just thought I would mention that. And if you're on Azure, let's say, and using PowerShell a lot, then some advice I might have is, if you're already used to curl, something you can do quickly to get some PowerShell is to just use AI like ChatGPT and just say, convert this bash script into PowerShell using invoke-rest method, and it will do it all for you. It's amazing. Something else I want to show you is, if you're just for downloading specifically as a use case, you may want to consider wget instead, and this is useful for multiple files, going down several directory levels. It's also got better capability for, you can resume downloads if they're interrupted, and it can also do mirroring, and you may also find it more useful for doing simple downloading. So I want to give you an example here, because it uses basically less switches compared to curl. So if I clear the screen and I go back and I just copy this link again, and it also gives a better experience. So we know that that has a redirect, so I'm going to say and I'm going to say, as an example, we're going to call this curl download.zip. I know it's not a zip, but it doesn't really matter. And I forgot to put that we know that it needs to follow the redirect, so let's put the URL in, and this is what we get. Now wget is different, so we need to use a capital O, and I'm going to call this wget download.zip instead, and that's it. It will automatically follow any redirects, and also it will give a slightly different, you're going to see now a different experience. So let me press enter, and I would say it's a richer experience. You can even see here that it went there and it followed it to actually the real URL. And look at this. This is interesting. You can actually see, and there's probably a way to get this from curl, but wget gives it to you automatically, that it actually has gone here. In fact, this is the redirected URL here. It's actually hosted on google.com, which is super interesting. I think, did Google make Golang? I'm not sure. But anyway, the redirect URL is not go.dev, but it's actually dl.google.com. So that's pretty cool. And then it went there and it downloaded it, and it gave you some information about it. And yeah, I think it's pretty cool. So it is an alternative, and you may consider using this. And finally, for testing APIs, curl works really, really well. However, if you need to do a lot more testing, and testing with a lot more complexity, then you probably want to use a dedicated API testing program. And the most common one is Postman, but there are other ones. But just as a starting point, if you want to investigate, I would suggest that you look at Postman. It's super popular and good for most use cases. So that's it. I hope you enjoyed this video on using curl for DevOps Cloud engineers, and check out my other videos for more like this. Thanks a lot. Bye bye.